solution? The solubility of the solution, fine. And clearly, it is a function of temperature, fine. It will vary with the changes in the temperature, fine. Then we talked about two comparative terms, that was concentration and the dilution. To figure that out, to calculate the concentration of a solution, we use three methods, either volume by volume, mass by mass, or mass by volume concentration. All of these, they are in the percentage units. So we calculate the percentage of the concentration of the solute in the solution. Fine. Now, next problem. Generally at your level, we are dealing with the mass by mass concentration. We are just dealing with the mass by mass concentration. And in that method also, we can have three approaches to that question. Yes. First is mass of the solute is given, mass of the solvent is given. We can calculate the mass of the solution. Then we can calculate it in a direct way using the formula. Second method is percentage of the solute is given and total mass of the solution is given. Percentage of the solute is given and the total mass of the solution is given. So in that, what steps do we need to follow? First, we need to calculate the mass of the solute. How do we calculate the mass of the solute? Let's say we have 35% of the solute of the total solution. So 35 divided by 100 into the total mass of the solution. Yes? Yes, Bacho? Yeah. Let's say the total mass of the solution is 78 grams. Yes. And I say that percentage of the solute out of that 78 grams. See, please remember one thing, whenever we actually multiply it by 100%, we make a unit like the whole as 100. Yes. Then out of that we take it. Example, total mass is 78 grams. Out of that 35% is the mass of solute. So we'll calculate the mass of the solute. How will we do that? Can you tell me, Ramesh and Umayma? 35 by 100 into 70, the total mass of the solution. Fine. The third approach is when only the percentage of the solute is given or only the percentage of the solvent is given and we are not given the total mass of the solution. In that case, what steps will we follow?
We have to assume either the...
Exactly. We will assume the total mass of the solution, then it is 100 grams. Yes, then it is 100 grams. Then we can calculate it. Fine. Okay, Bacho. Any other problem in this?
No.
Okay. Please continue with the now we'll be discussing very quickly the properties of the solution. Please. So can I assume that you all know that solution is a homogeneous mixture? Yes. At times, Bacho, this can also be referred to as a true solution. Yes. It can also be referred to as a true solution. So in any case, if there's written true solution, please don't get confused. It just means solution which is homogeneous. That's it. Okay. So the first property, what is the first property? Clearly, it's a homogeneous mixture. Yes, it's a homogeneous mixture. And can I say that since it is a homogeneous mixture, it is one-phased. It is in one phase, Bacho. Yes.
What does
Second
phase
point
mean, man?
Phase means
Like
different
one
zones
phase.
or different separate. Yeah, one phase, two phases, three phases. Okay. So like
Okay.
separately, we cannot see it. It's all in one part. Yes, in one composition, as that can be seen. Right. So that we mean by that is what we mean by one phase. Okay. Secondly, it is homogeneous. Second part, can you tell me? Second property, Bacho?
It has
Any
a
property?
solvent
Any
and
idea?
solution. Can you write that?
Okay. That is the property. No, that is not a property, Bache. Can you tell me about the particle size here?
Solute particles
Please
are
recall
very
that
tiny
actual
and
dissolve. Yeah, they are actually very tiny. So the particles in a solution, are not visible to the naked eye. Yes. And why are they not visible? Because they are very small, and we will discuss the size. But the size is less than 1 nanometer. And 1 nanometer, what is it? 10 raised to the power minus 9 meters, right? So if the size is 1 nanometer, that is not a solution. The size has to be less than 1 nanometer for it to be a solution. Yes, Mohammed, done?
Sure.
No.
Am I done?
Yes, ma'am.
The third is Bachu. Please pay attention. What happens? This is a stable solution. This is a stable mixture. And we will understand what do we mean by stable mixture because it's a solution. Right? See. What happens? Let's say we mixed sugar in water or salt in water. We have mixed it properly. Okay. Now, if we leave that solution for some time as it is, okay, undisturbed, what will happen? Will the salt particles settle down at the bottom of the container? Will they separate out from the water particles? Yes or no?
No.
No.
No. No. Yes, they will not separate out because they have actually been mixed properly. So in case if we
Yes.
leave the mixture as it is for some time undisturbed, if the particles do not settle down at the bottom of the container, they remain as it is properly mixed, then that means it is a stable mixture or it is a stable solution. Fine. Now, if it is a stable mixture, if it is a stable solution, that means if the particles are not getting settled down at the bottom, clearly we will not be able to use the filtration method here. Will we be able to filter the solute here? Will we be able to filter the salt particles here, bacha?
No.
No. Why? Because they have not settled down. So stable mixture means the particles are not settling down at the bottom because they have been mixed very properly. And the second reason is that because the particles are so small that the gravity does not apply much onto those small particles. Is it clear?
Yeah.
Please write it down. We'll move on to the next point. You can write it here in a bracket. Filtration is not possible here. Why? Because it's a stable mixture. What happened, Mohammed? Any problem?
No, ma'am. It was just lagging a little bit. But can you give me just 1 second? Yes. Sorry for that. Okay. So the 4th point, bacho, what is the 4th point? Can you tell me what will be the 4th point, bacho? We have to discuss a very important effect which is called as Tyndall effect. So first we will discuss the Tyndall effect. What happens, bacho? Hello? Yes. Sorry. So the 4th point is we have to discuss the effect which is Tyndall effect. What is Tyndall effect? Any idea, bacho? Any idea? No. No, ma'am.
Ma'am, spreading of light.
Who is this, bache?
Abdullah.
Oh, Abdullah has joined in. Okay. Yes. Yes, Abdullah, please answer.
Spreading of light in a solution.
Okay. Okay. See what happens. Very well said, Abdullah. Yeah. Actually, the word is not spreading, but rather scattering. Okay. So what happens? Well then, no worries. What happens if we have a beam of light, okay, many rays of light, and if they actually interact or collide with some particles, let's say we have some particles here, okay. So if the particles are very small, bacho, if the particles are very small, they will not be able to change the path of the light. Yes, that means they will not be able to scatter the light, the beam of the light, okay. So if the light is not scattered, we cannot see the path of the light. You getting it? If the light is not scattered, we cannot see the path of the light. If the beam of light gets scattered, we are able to see the path of the light. And when the particles are big enough, then they are able to scatter the beam of light. If the particles are very small, they are not able to scatter the beam of light. Okay. So this scattering of light and when the path of light is visible because of the scattering of light, because of the particles, then it is referred to as Tyndall effect. Then it is referred to as Tyndall effect. Fine. Now, in case of solution, bacho, since the particle size is very small, yes, since the particle size is very small, what is the size of particles in solution? Less than 1 nanometer.
Less than
Less
1
than-
nanometer.
Yeah. So it is less than 1 nanometer. That is very, very, very small. Therefore, the particles are not able to scatter the light. Yes. When the light is not scattered, can we see the path of the light? Yes or no?
Yeah.
No. Wonderful. Therefore,
No, ma'am.
Tyndall effect is not shown by the solution. Okay. The property is Tyndall effect is not shown by the solution. Is not shown by the solution. And please write the explanation and the reason in your own words. Because light does not get scattered because the particles are very small. Abdullah, you writing?
Yes, ma'am.
Done, bacho?
Yes, ma'am.
See, look here. It's still right. Write it, write it.
Yes, ma'am. Done.
Done.
Yeah. Mama, write it done.
Yes, ma'am.
Can you tell me some real life examples of Tyndall effect? Where do we get to see the Tyndall effect? See what happens. Often you must have seen that what happens when light enters a dark room, okay, a dark room through a small hole. Then we are able to see the path of the light. Yes or no? Yes.
Yes, ma'am.
What happens? The small dust particles, the particles which are there in the room, okay, they scatter that light. They scatter that beam of light. Hence, we are able to see the path of the light. If the scattering was not taking place, we would never be able to see the path of the light. Is it clear? And we will study further why are the atmospheric particles able to scatter the light. Okay, we will learn about their size. Fine. Is it clear? Any other example?
Yes, ma'am.
Does mist scatter the light? Mist that is there in the atmosphere.
Yes, ma'am.
Yes, ma'am.
So this effect is often seen in the forests which are very dense. So when light actually comes in, the mist particles which are present there, they are able to scatter that light. Hence, the path of the light becomes visible. I hope Tyndall effect is understood. Any problem in Tyndall effect?
No, ma'am.
Ramesh, Mohammed,
No.
Ma'am,
Umaima.
in clouds, there's no Tyndall effect, right?
In clouds,
Yes. Can we give an example of clouds?
can you tell me, but how are we even going through that? Like, how is the light reaching that clouds?
What, can you repeat?
Yes. My question is, how is that beam of light reaching through the clouds?
The sun, I'm talking about the sun.
Yeah, but we are able to see that because
No.
we are able to. I'm saying we are able to see that when it gets scattered by the mist, not otherwise.
Okay. Okay, I understand.
No, but I'm still not able to understand your question properly. Can you say that again?
Yeah, my question was something else. It was not not correct.
No, don't worry for that. After the class, wait for a minute. We will discuss that because I'm still not able to understand your question properly. Fine.
Ma'am, can you give me 5 minutes?
For Maghrib,
Yes, ma'am.
go quickly. Fine. So the next we are starting with the heterogeneous mixtures. Okay. So we studied about matter, pure or impure matter. We discussed about the pure matter being elements and compounds, right? Impure matter, it is referred to as mixture. Now, mixture is also of two types. What is that? What are those two types, Bacho? Abdullah?
Heterogeneous and
Homogeneous.
homogeneous.
Yes, heterogeneous and homogeneous. So we have discussed the homogeneous mixture, which is referred to as a solution. Now we need to discuss the heterogeneous mixtures. Fine. Quickly tell me some of the properties of heterogeneous mixtures. Is Khadija there, Bacho? Khadija?
Yes, ma'am.
Yes. Beta, can you tell me some of the properties of heterogeneous mixtures? Yes.
Ma'am, like the composition of them isn't uniform.
Rameez Abdullah. There's some problem in my internet connection. Just a second.
It is not in one phase.
Sorry, Beta, can you repeat?
It is not in one phase.
Yes, it is not in one phase. Very good. It is two phase. Okay, good. Second,
Like you can see this, like it is visible, the
it,
solid,
the,
the
yes,
boundaries,
the particles. Yes,
particles.
the particles are. We have a distinction between the particles. Yes, clear. That means it is not in one phase. That means it is two phase. You can write it like that. Okay. Any other point, Mohammed?
It helps with Landon effect.
Sorry.
1 minute.
No, you're getting confused. That's not with that.
It is not a stable mixture.
We cannot say that right now. We will see it.
Can be
Okay.
seen by naked eyes.
Not really true.
Ma'am,
Yes.
they have
Bacho,
like
yes, just a second, Khadija, beta. Recall the properties that we studied for homogeneous mixtures when we were trying to differentiate between the two. Okay. Then try to answer. Yes, Khadija, please answer, beta.
they have like different composition and like properties in like the solution.
Yeah, that is but obvious, but like, why do they have so? Yes, Abdullah.
Ma'am, there is no chemical.
Go through that again. You have recall the properties of compounds, bache, or compounds and mixtures. Whenever
Um,
there is a mixture,
Can we,
whenever
ma'am, can
there is
I
a
say one
mixture,
thing?
just a second moment. Whenever there is a mixture, there is no point of chemical bonding. Yes, we are talking about two different types of mixtures. There will be no point of chemical bonding in each and every type of mixture. There is physical bonding. Okay. And after that physical bonding, there are some differences that we need to discuss. Yes, Mohammed.
I was saying, can we say that there is no uniform composition?
Yes, there is no uniform distribution. Very good. Good. There is no uniform composition. There is no even distribution. Very good. Any other point, bachcho? The
It does
boundaries of
not.
the particles. Yes, yes, Amis.
It does not involve a substance dissolving into another substance.
See, you can say that actual dissolving does not take place. Yeah, that's the correct part. Yes. So dissolving does not take place here. Rather, the particles of one substance, they are suspended in the particles of another substance. Okay. The particles of one substance, they are suspended in the particles of another substance. Dissolving does not take place here. Okay, bachcho? Yes, Khadija?
Yes, ma'am.
Okay. Do let me know if I should write any point here, or I hope you have written it all, else I'll write it, no worries.
Ma'am, can you write it? It'd be better.
Yeah. Fine, bachcho? Is Umema back?
Yes, ma'am.
Yes.
Done, ma'am.
Done. Acha, can I ask you one question here? All five. Can we separate the heterogeneous mixtures through physical methods of separation?
Yes, ma'am.
Yes.
Yeah.
Yes.
Yes, ma'am.
Okay. Can we separate the homogeneous mixtures through physical process of separation?
No.
No.
Yeah. No.
We can.
We can. We can. Yes, Abdullah?
Yes, ma'am. I think yeah.
Arami?
Some we can. Some.
Umema? Khadija? Can we separate the homogeneous mixtures through physical methods of separation, bachcho?
Yes, ma'am.
We can. Ramesh?
Yeah.
We can. Bachcho, we can because it is a mixture. Why did all of you first say we cannot? Though it's a homogeneous mixture, but it is a mixture. There is no chemical bonding that has taken place there. If no chemical bonding has taken place, therefore we can always separate them using physical processes of separation. Is it clear? The point was
Yes, ma'am.
filtration is a type of physical process which cannot be used in just solutions, which is a homogeneous mixture. Filtration is a type of physical process of separation, yes, that cannot be used because of the size of the particles. We have other processes like evaporation, like distillation. Those are all physical methods of separation, and they can be utilized for separating the particles in a solution. I hope this point is clear. Do not get confused between this. Compounds which are pure substances, they cannot be separated by physical methods of separation. All types of mixtures can always be separated out by physical methods of separation except one mixture. What is that?
Ma'am, can you
What is that?
repeat?
Huh?
Can you repeat?
Yes. All types of mixtures, all the mixtures can be separated out by physical methods of separation except one mixture. What is that mixture? I do not want the wrong answer. Okay, I just want the correct answer. Tell me one thing, if I am saying that cannot be separated out by physical methods of separation, can you tell me what kind of bonding exists in that mixture?
Chemical bonding.
Chemical bond. And in what mixture does chemical bonding exist?
Compound.
Compound is a mixture.
Homogeneous.
Homogeneous mixture. Salt and water. Does chemical bonding take place?
No.
No. Then there's just one mixture that can be separated out, with that cannot be separated out by physical methods of separation. Recall. Go through your notes. Go through your notes. There's something called as alloys.
Yes, hello.
Yes, ma'am. Yes. Huh? Yes, Mohammed, Rameez, Umama, Khadija.
Yeah.
Alloys, they are mixtures. They have all the properties which are more inclined towards the properties of a mixture. The only difference is that they have chemical bonding and hence they cannot be separated out by physical methods of separation, but they are mixtures. Yes?
Yes.
Yes or no? I hope it's clear
Yeah.
now. So moving
ma'am.
on to the heterogeneous mixtures. I hope all of you have written the properties.
Yes, ma'am.
Yeah.
Yes.
The heterogeneous mixtures, they are further divided into two types. One is a suspension. A suspension. The other is a colloidal solution. That is why I told you at times when we are referring to true solution, that means a homogeneous true solution. Okay. Yes, Victor. Done. See.
Yes, ma'am.
Yes. Can you tell me what happens if we mix sand and water? Will it mix? Will it mix properly?
Ma'am, can you repeat?
I am saying what will happen if we mix the salt and water?
Yes, ma'am.
It will mix.
Hello, am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Oh, just a second, but sharing is still not allowed. Hello? Yes. What happens if we mix salt and water? Will it mix?
Yes.
It will get.
Yeah.
Yes.
What happens if we mix sand and water?
It won't mix.
It won't mix.
It will not. Right? So what according to you is the reason of sand and water not mixing together?
Because the
What and
particles are
water?
not.
Sand and water not mixing together.
Yeah,
Yes, Bacho.
because
Because the sand
particles of
particles
sand
are
are bigger
Yes, ma'am.
inside.
large.
Yes, they are larger in size. Fine. So suspensions are a type of mixtures which are heterogeneous because of the size of the particles. Okay. So very important points. We are going to discuss the properties of suspension. But first point here, Bacho. In case of solution, we discuss the solute of the solution and the solvent of the solution can be in either state, the solid, liquid, or the gaseous. Yes, the solute can also be in the solid, liquid, gaseous state. The solvent can also be in the solid, liquid, or the gaseous state. Okay. Similarly, in case of suspension, we can say that the particles which are mixing and the particles of other substance, okay, both of them can be in any state. But at your level, we are generally considering the suspension where one particle is solid, the other particle is a liquid. Is this point clear? Please keep this point in mind when you are going through suspensions, right? Because otherwise, pizza is also an example of a suspension. Okay. But in this, at this level, we are not going to discuss that type of suspension. So the first property of a suspension, Bacho, is this a homogeneous or a heterogeneous mixture?
Heterogeneous.
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 Very good. Okay, heterogeneous mixture. Secondly, the particles are visible to the naked eye. Please write it.
Yes, sand particles are visible by the naked eye, right?
Yes. But to the size of the particles in suspension, this point is not discussed in the NCERT, but please write it down. The size of the particles in case of suspension is more than 1000 nanometers. Okay. Clearly, you can see the difference. And 1 nanometer is equal to 1 meter raised to the power into 10 raised to the power minus 9. Okay. That is the relation between nanometer and meter. Can I move on to the third point?
Yes, ma'am.
Now, clearly the particles are so big, dissolving is not taking place because it's a heterogeneous mixture. Will this solution be a stable solution or will this solution be an unstable solution?
Unstable.
Just recall, yes, very good. Just recall if we mix sand or soil into this water, will it get settled down after some time?
Yeah.
Yes. Therefore, it's an unstable mixture. Okay. And if it is an unstable mixture, will filtration be okay here? Can we separate them using filtration?
Yeah.
Yes. Abdullah, writing it?
Yes, ma'am.
Khadija, writing it?
Yes, ma'am.
Okay. That fourth point, bacho, if the particles are big enough, will you think, what do you think? Is Tyndall effect shown by the suspensions? Yes or no?
Yes.
Yeah.
Yes, ma'am.
Yes, because the particles are big enough to scatter the beam of light. If the beam of light gets scattered, definitely the path of the light is visible. Therefore, Tyndall effect is shown by the suspensions. Okay. I hope you have written it down. What do we mean by stable and unstable solutions? Okay. Is the screen visible?
No, ma'am.
No, ma'am.
No, ma'am.
Okay, there's some lagging. Just a sec. Is it visible now?
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay. Hello. Yes, sorry for that, Bacho. Some technical issues. Okay. So Tyndall effect is not shown by the suspension. Fine. Can you quickly give some examples of suspensions? Is everyone there?
Yeah.
All are. Yes. Some examples of suspensions, Bacho.
Chalk and water.
Chalk and water, very good. Yes,
Sand and water.
wonderful. Sand and water. Acha, tell me, is milk suspension, Bacho?
Yes, ma'am.
Yes.
Yes.
See, remember, in general life, we might classify milk under suspensions, okay? But we have to follow what the NCERT says. And the NCERT classifies milk under colloidal solutions and not suspensions. Fine. Blood is one example of a suspension. Okay. Blood clearly is an example of a suspension. We have cells which have the size as comparable to the size of the particles in a suspension. Therefore, blood is a suspension. So never classify milk under suspensions till at least you are pursuing NCERT books. Okay. Done, bacho?
Yeah.
Yeah. Moving on to the next type of solution, that is colloidal solution. Yes, colloidal. What is a colloidal solution? Any ideas? Yes, Umama? Any idea, bacha? See, it is referred to as a solution because it has properties somewhat, it appears to be similar to a solution, but actually it is not. First of all, it is a heterogeneous mixture, that is for sure. But the point is, it appears to be like a homogeneous mixture, but is actually a heterogeneous mixture. Okay. So first point, very important, it appears to be like a homogeneous mixture, but is actually heterogeneous. Okay. See what happens. The particle size in case of a colloidal solution is between 1 to 1000 nanometer. Okay. That is between the size of the particles in solution and suspension. So this particle size is between 1 to 1000 nanometers. So it might appear that it has been dissolved properly because of its small size, but actually on the microscopic level, it is not dissolved. Therefore, it appears to be homogeneous, but is actually heterogeneous. It appears to be of uniform composition, but that uniform composition is actually not present. Please write it down. It appears to be of uniform composition, but is actually not there. Abdullah, you writing it? Abdullah, turn on the camera. Fine. Next point,
Yes,
bacho.
ma'am.
Yeah. Next point. Wrote it down?
Yes, ma'am.
Rameez and Mama writing.
No.
Done? Yes. Next point. Since, what do you think? Because the particles are of this range, what do you think? Will it be a stable solution or will it be an unstable solution?
Stable.
Stable. It is a stable solution. Very good. It's a stable solution. Okay. It is a stable solution. That means particles do not get settled down at the bottom of the container if left undisturbed. Mohammed, if it is a stable solution, will filtration be okay to separate the particles here? Can separation be used to separate the particles here? Oh, sorry, filtration be used to separate the particles here?
Yes, it can be used.
It cannot be. If
How, ma'am?
if the solution is stable, That means particles are not settled down at the bottom of the container. We cannot utilize the
Oh,
process
okay.
of filtration. Okay. Okay, bachcho? Filtration not possible. Please write the reasons in your own words. First of all, size is small. Therefore, it might appear it has mixed. Some of the particles actually get mixed, but overall it's not a uniform composition. Secondly, because the size is small, so the force of gravity is not much here. Okay, bachcho? Now, last point, Tyndall effect. What about the Tyndall effect, bachcho? Will light beam get scattered by these particles, size of these particles?
Yeah.
Yes.
Yes.
Tyndall effect is shown by colloidal solutions. Very good. Yes. Now, can you tell me that milk, which appears to be homogeneous, is it really homogeneous, or does it appear to be homogeneous or heterogeneous? What is the case with milk?
It appears to be homogeneous.
Homogeneous.
It appears to be homogeneous, but is actually not homogeneous. Because since it is appearing to be a homogeneous mixture, we definitely classify it under the colloidal solutions and not suspension. Fine. Moving on to the next part. Done, ma'am? One question, bachcho, in between. Copper sulfate solution. Copper sulfate solution. Yeah. Is it a colloidal solution? Is it a true solution? Is it a suspension? What is it? Or is it a pure substance?
What, copper?
Ma'am,
Copper sulfate solution. The name of this solution is copper sulfate solution. Yes, bachcho. Is this a true solution? By true solution, you must understand I'm referring to a homogeneous solution. Yes. Is it a colloidal solution? Is it a suspension? Or is it a pure substance? Open up your NCRTs. Open up your NCRTs.
Ma'am, can I go get it?
No, just wait a second. I'll actually show you here. Then you can mark it.
Ma'am,
See,
I
bachcho.
think it is an homogeneous mixture or a
Very
true solution.
Very good. See, solutions of copper sulfate does not show Tyndall effect. Now, clearly, it's not written here that it is a solution. But what is written here? It does not show the Tyndall effect. If some mixture is not showing the Tyndall effect, then what is it? Is it a suspension or a colloidal solution? Both of them show the Tyndall effect. So what does not show the
Yes.
Tyndall effect? It is a solution or a true solution. Okay. So please
I
refer to
we have
each and every. Yes,
we have done this experiment in the school, so I
Yeah.
remember.
good. So please refer to each and every activity, each and every diagram, each and every point of the NCRT very nicely. Now, coming on to the points of suspension and colloid. Please, but to pay attention. In which solids that disperse in liquids are called as suspensions. Disperse means they are not dissolved. They are there as it is. They are suspended. Okay. They are dispersed in the liquid. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Bulk of the medium as in all throughout the medium. Fine. Particles of a suspension are visible to the naked eye. What are the properties of the suspension? It's a heterogeneous mixture. Particles of a suspension can be seen. Good. What is the size of the particles here? Umema? Suspension, bachcha? More than 1000 nanometers. The particles of a suspension scatter a beam of light passing through it and makes its path visible. Therefore, it shows.
Tyndall effect.
Tyndall effect. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. The suspension breaks and does not scatter light anymore. Very important point, bachcho. When the particles settle down, the suspension breaks and it does not scatter light anymore. Is it clear? Because then it is not dissolved, it is not suspended into each other. Then it's no more a mixture. Okay. Coming on to the colloidal solutions. This point is very important. I hope all of you have marked this in your books. Very important. Then, coming on to the colloidal solutions. See, the particles of a colloid are uniformly spread throughout the solution. We will discuss why. Due to the relatively smaller size of the particles as compared to that of a suspension, the mixture appears to be homogeneous, but actually a colloidal solution is a heterogeneous mixture. For example, milk, very important. Fine. Now see, we have they say here that it's a uniformly spread mixture. Is it true? Why have they written it here that it's a uniformly spread mixture? Because they mean that it appears to be homogeneous, okay, because of its uniform composition.